This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I'm going to show how to graph a rational function. So here's a typical assignment. This says, for the rational function below, find the whole, the vertical asymptotes, the horizontal asymptote, the x-intercepts, the y-intercept, and the point where the graph intersects the horizontal asymptote, and then sketch the graph. Okay, and then we're given this rational function. It's all factored out. So we've got f of x equals x plus 4 times x minus 1 times x plus 3 over x plus 3 times x plus 2 times x minus 5. So what we're going to do is find each of the things we're required to look for, and then we'll use that information to draw the graph. We'll start out looking for the whole in the graph. I've got an x plus 3 in the numerator and an x plus 3 in the denominator. So that means we could cross both of those factors out as long as we remember that there's going to be a whole when x equals -3. What I want to do is find out what the y is going to equal when x is -3. So I find out the exact location of that whole. So I'll take what I've got left of my function and replace the x values with zeros. I'm sorry, with -3s. So I'm going to have -3 plus 4 times -3 minus 1 over -3 plus 2 times -3 minus 5. So -3 plus 4 is a +1, and -3 minus 1 is a -4. -3 plus 2 is -1, and -3 minus 5 is -8. I multiply the numerator, I get a -4. The denominator is going to become a +8. So that means this fraction, -4 over 8, is going to equal just -1/2. So the whole is going to be at 3, -1/2. Okay, let's clean this up and go on to whatever we're looking for next. We need to find the vertical asymptotes and then the horizontal asymptote. So the vertical asymptotes are going to occur when the denominator is equal to 0. The factored denominator, without that x plus 3 where the whole is, it has an x plus 2 and an x minus 5. So we're going to have vertical asymptotes at x equals -2 and +5. The horizontal asymptote is something we can find by looking at the degree of the two polynomials and also the lead coefficients. If I were to multiply all this out, I would find out that both of the polynomials began with an x to the third. So if they both have the same degree and the same lead coefficients, which they would, the horizontal asymptote would be at y equals 1. Okay, after that we want to find the x-intercepts and the y-intercept. Okay, so for the x-intercepts, the x-intercepts are going to happen when the function equals 0, which would happen when the numerator equals 0. So if I've got an x plus 4 as a factor in the numerator, then x equals -4 would be a location for an x-intercept, and x equals +1 would be where the other x-intercept is. For the y-intercept, what I want to do is see what would happen if all the x's were turned into zeros. In other words, if the value of x was 0. So I would have a +4 times a -1, that would be a -4, and a +2 times a -5, that would be a -10, and that just becomes, I'll make that into a decimal, it's going to be 0.4. So the y-intercept is going to happen when y equals 0.4. Let me go back and get rid of that. Okay, and the last thing we have to find is the point where the graph intersects the horizontal asymptote. Okay, the horizontal asymptote was 1. So what we want to do is take this fraction and set it equal to 1 and find out what x would be when it equals 1. So I'm going to have x plus 4 times x minus 1 over x plus 2 times x minus 5. X plus 2 times x minus 5. I'm going to say that equals 1. Let's multiply the two binomials in the numerator. That's going to give me x squared, let's see, plus 3x minus 4. The denominator is going to become x squared minus 3x minus 10. We'll set that equal to 1. I want to multiply both sides of this equation by the denominator here. So I'm going to get x squared plus 3x minus 4 equals x squared minus 3x minus 10. I can subtract x squared from both sides. I'll just cross those out. I can add a 3x to both sides and add a 4 to both sides. When I add 3x to both sides, I'm going to get a 6x. When I add 4 to both sides, I'm going to get a negative 6. So x would equal negative 1, which means the point, let's make some room for the answer. The point where that intersection is going to happen is going to be at negative 1, comma 1. The 1 because that's what the horizontal asymptote was. Okay, so now we've got all the information we need. We should be able to draw a graph from this. So I've got my graph here. Let's see if we can just fill in all the information on it. I'll put in the vertical asymptotes. That was at negative 2 and 5. So I have the dotted line along x equals negative 2 and the dotted line where x equals 5. The horizontal asymptote was y equals 1. So here's the dotted line for the horizontal asymptote. I had x-intercepts at x equals negative 4 and positive 1. So that means we're going to go through the graph at x equals negative 4 and x equals positive 1. I had a y-intercept at y equals 0.4. So that would be approximately here. You'd probably want to write that in. Let's see if I can put it in 0.4. And we had an intersection of the graph and the horizontal asymptote at negative 1, comma 1. So we're going to have a point negative 1, comma 1. And I'll put that hole in last. Actually, I'll put it in right now. The hole was at negative 3, comma 1/2. So negative 3, comma negative 1/2. That would be right about there. Okay, now we just have to draw the curves. So since we have a horizontal asymptote at 1, we know we're going to start our curve somewhere along this y equals 1. And since it has to go through the first thing it's going to do is go through the x-axis. It's going to curve downward, go through that point x equals negative 4. It will go by that point where the hole is, and then it will continue to curve down along that first vertical asymptote that I have at x equals negative 2. Then we'll start up again at the top of the graph. We're going to curve downward through this point negative 1, comma 1, through the point 0, comma 0.4, down through the x-intercept and continue to curve down towards that vertical asymptote. And then the last thing it's going to do is start up again at the top of that vertical asymptote and curve towards its horizontal asymptote. Okay, so that's basically the process. It's just a bunch of simple steps. It seems like a lot. Well, it is a lot. But each of the steps is fairly simple. The steps are things you know how to do already. And then once you've got all the information in, you just draw that graph. Okay, so take care. I'll see you next time.